It's my pleasure to welcome our guest speaker of today, Martin Haagoort, who is the CEO of, well, you already see one of his slides, but Intellerts, which is also a company active in data science domain. I've heard Martin speak before. He gave guest lectures before, and that was, well, I think a very interesting talk. He gave before. I think this will be another nice and, well, interesting talk about what you would do with data science. And I guess you introduce Intellerts at more, so I'll give you the word, Martin. Please go ahead.
Yeah, well, thanks, Ger. Thanks for the opportunity. I'm Martin Haagoort. So I have a background in econometrics. More than 33 years ago, I did that. Now I'm running a company called Intellerts. We are what we call ourselves a data science / AI company. So what we do, we create data science solutions. We have done quite a lot of startup support. We created a couple of companies ourselves, more by accident than by design, I must be honest to say. That's very exciting. We are broad in the services we provide. And I'll be sharing my experience condensed in a couple of slides on what we see in data science. And as my title of the talk is called, "There is no plug and play in AI." Well, first of all, the term AI is misleading, as some of you know, because everything is now AI, where this is just the latest buzzword. What is real AI? What's not real AI? Is it overhyped? Is it overpromising? Is it under-delivering? I'm hoping that I'll provide you some pointers in order to be successful in applying analytics in your future steps in your career. So these are the things that I want to address. Kind of try to debunk a bit the noise around AI. You have I would assume, a very good view of what AI is and what it's not. But I want to confront you with some perceptions that are out there in the business that you have to overcome and sometimes need to fight. I want to talk about the journey of data science and the process of data science. I want to talk about the analysis of analyses. So there'll be an E at the end of the second analysis, to be precise. There's lots of different AIs around, you could say. I want to talk about the process of decision making. I want to briefly talk about the challenges it has for IT. I got one very busy slide on what I call the competence framework for data scientists or business analysts or AI specialist, whatever you want to call it. And then last but not least, some findings that we run into when we are implementing these phenomenal technologies and techniques. Now, first of all, there's so much hype. There's so much, sensationalized talk about AI as if it's going to solve, the human problems we have. So we're confronted with that, and that basically results in a lot of news that is really not substantiated by anything. And the reason I'm bringing it up, because a lot of your future workers, clients, customers, they will have certain expectations that are not underpinned by pure science. There are ridiculous expectations with regards to AI. A lot of tech prophets actually claim that we will create a super intelligence, and there is actually absolutely no kind of evidence for that will happen. So it's important to really understand what kind of perceptions are out there. I already mentioned AI is not plug and play. You might think it is plug and play if you listen to all the tech companies. It's absolutely not the case. It's also not true that technology will make things easy. Of course, technology is making some things easier, but very often technology makes things more complicated. I will come to that. But very often people have wrong understanding of what the computer does and what our brain does, and confuse the two things and think that when our brain is functioning as a computer, then it's quite logical to assume that there will be a computer that is better than our brain. Well, that's a myth, and that is absolutely not substantiated by any science or any expert in the field. But it's an important metaphor that's being used and abused by many in the technology world, as well as that also people are infected by it and therefore have ridiculous expectations of AI. And as I said, AI is kind of a group word for many things, sometimes very simple business rules or a simplistic algorithm is already grouped right now under the term of AI. So we need to be watchful for that and really look at what's under the hood. And this is really AI that they're talking about. Very often they talk about AI, but they need something else. So we spend quite a lot of time to explain what things are and what they are not. For example, people think that an algorithm is a living thing, where an algorithm is just inherently dumb. It might be obvious to you, but it is not to the majority of your sometimes highly educated audience. So something to bear in mind. I like this definition of David Belinsky. It is absolutely dumb. That's not the overall perception. There are many definitions of AI, and of course, I don't need to explain to you what AI is, but you need to try to make it so simple that it's actually debunking the myth that it kind of is being created into. So I think this is one of the best definitions I've seen. Is from Professor John Lennox, and he basically said it is sort, filter, select. It kind of you could say, well, that is too simplistic. You could say, well, in essence, it does that, only that. There's an element of learning and there's a statistical test. And that's the whole story. And then we can make it very complicated. You can describe it, you can use a lot of terminology, but it's sort, filter, select. And this helps to put people back to where I think AI is supposed to be. So the journey of data science, and kind of drawing it as a black hole of data. And this is the biggest problem that companies have. They come to you and they want business optimization, they want algorithms, maybe they even have an ambition to do AI in some sort of way, and they all underestimate and they forget about the complexity of data. So when you go on a journey of data science, it is, of course, it says the term data. There's no much science to it yet. It's basically a black hole of data. Now, of course, we are claiming, and we can prove that we do a lot of complicated AI stuff and optimization, machine learning, and NLP. We all do that. But you start with data, you curate the data, you massage the data, you have to manage and understand the data, and then you're going to start with some simple things, which are very important. Don't forget that 90% of the companies are coming to you for optimization of something, and they end up doing simple visualizations of the reality that they live in right now. So it's important, and you have to offer BI before you can move on. Business intelligence. Most companies ask algorithms and AI, but they need business intelligence. So on this journey, we basically say, okay, you start with the data, you structure the data, you curate the data, you start with visualizations, then you go into alerting, you're going to work together, and then you might get into the phase of being predictive or prescriptive with some kind of model, being it AI or just traditional statistics or what have you. So questions. You could say, okay, where are we then really? What is the level of maturity that we are at with AI? What can we do to accelerate? What is a route for companies to get onto this track? So it all starts with asking questions. Like this quote from Picasso said, computers are useless, they only give you answers. And that's a good point, because it starts with asking questions, and asking questions is a difficult thing. It's a difficult thing I find with a lot of people that come from university, because they want to, as soon as possible, apply their machine learning algorithm or their optimization techniques. But as you know, it is only step 6 or 7 in the process. It all starts with asking questions, reviewing the sources, understand the sources, integrate, explore the data, get people into your domain or into your project that have the real domain knowledge. Then you can start modeling the data. Visualizing the data is becoming more and more a specialization in itself, even within the data science. You know, you have this whole spiel with data storytelling and all kinds of strong tools, and you need to communicate. So this is not rocket science. Again, I'm not sharing any rocket science today with you, unfortunately, but it's quite often not followed. So model the data is, of course, something that you would really like to do most of the day. We all know that data scientists only are about 20% of the time, if we are, optimistic, really doing that piece of the work. Then you can say the algorithms are free. That's true. It's already the case for a long time. But building solutions takes a lot of time and effort, and therefore you need to go through this whole cycle. Actually, tools are free as well, so that's really confusing for a lot of companies. So the algorithms are free, the tools are free. So why is it so complicated or complex, whatever definition you want to follow, to create solutions in AI or in data science? So one thing that is very important to note, very simple graph, where I guess it comes from a guy called Heckleton, if I'm not mistaken. And this very simple graph basically tells you that you need to get to the data fast if you don't want to lose value. Now, we often talk about, okay, let's do a complicated analysis, or what is the process we need to improve, or the decision to support. But most of the time most of the value is lost, and often also most of the time is lost by simply getting to the data. It's important to understand. We see of the people that we get in our companies with regards to with a background in data science, in computer science, in analytics, that there's a lot of attention being paid in most of the university curricula on analysis and decision support, but proportionally there's not enough time spent on understanding data, data structures, data massaging, data curation, data modeling. That is a big gap in many practical applications, as well as in theoretical support from studies. So that's the important thing. The second phase is then, okay, we're going to do some kind of analysis. Here, I want to emphasize, and I'm probably preaching to the converted here, but just to be sure, I see two schools of thought. As you know, there is statisticians and mathematicians, and there are machine learners. Okay, I guess you have a better grounding into the traditional mathematics and statistics, but there is a new class of people coming on board that just take a few algorithms and they start to do these things that I now plot on the chart. Okay, there are more routes to Rome, and it depends on the one which religion. Sometimes it seems to like to be a religion if you're from this school or that school, and then the machine learners seem to be winning because they say, well, machine learning always outperforms traditional proven other techniques. And we all do the same thing. You know, you could do with the old school mathematics and statistics, you can all do these things, and you can do it with machine learning based techniques. So that's all true. Now, there are the variations, of course, but for certain types of problems, you can better use machine learning. There's a good set of examples for that, and for others, traditional works much better. But what is important to realize is that the cost of automating it is much higher when you apply machine learning than when you use traditional models. Apart from the fact that the transparency is, all in all, although it gets better with machine learning, the transparency of models, the explainability of models is much better with traditional techniques. So there is a cost, a true cost of implementation, which often is much cheaper with a simple traditional model. And there is the explainability, which are important elements to consider when you choose a certain technique to implement. And we get quite a lot of students from university, and they're just dying to implement machine learning, and then they basically find out that it's great to do it as a one-time trick, but in order to automate it into an environment where it needs to run on a frequent basis, is a totally different story. And the way to illustrate that is basically looking at the IT challenge that is there in AI or in data science, or whatever you want to look at it. So if you look at the pure problem-solving piece, which is the small box in the middle, it's called machine learning code, is only a very small automation task in itself. You might have experienced that yourself. But if you look around the other processes you also need to take care of, and that is probably only going to be worse in the coming years because of regulation, because of auditability, because of explainability. There's quite a lot of things you need to organize in order to implement a model, maintain the model, supervise the model, deploy the model. So that is horrendously complex. You probably have played with a couple of tools in this space, and bringing a machine learning code, doing it as a proof of concept, as a pilot, is not too difficult. You get the data, you massage the data, you do your feature extraction, and you run the code, and you get some outcome. You do some training and what have you. But bringing that product then into an environment to automate is really something that is very complex, and there is no easy way to implement these things. So that's important to consider, versus if I would have a very simple mathematical model, it is a very simple programming effort, and it's relatively simple to monitor. So that with regards to the I think Google calls this the technical depth of AI. So it's a good article about this from Google, that this is one of the biggest challenges that we're going to face in the future. Now, so that's the technical side of things. But then you find actually out that, okay, well, we say a few things about the data complexity. We say a few things about modeling data and modeling the problem, but that's only technology. What I'm trying to describe here is the process of creating products that people are really going to use. You might say, well, my model is the product, or my analysis is the product. But if you take it one step further, with any innovation that you will be involved with, there is going to be an implication of the associated workflows that follow. So I'll give you a couple of examples later on, but what I'm trying to say is that, well, I'll give you one simple example to start off with. For example, we investigate anomalies in financial administration, in invoicing. So what we do, we go through hundreds of thousands of invoices and we find anomalies. For example, we find out which invoices do not have the correct VAT % or calculation. That's a fairly straightforward task. Okay, there's a lot of business rules involved, but it's fairly straightforward. If you now look at the task from an accountant point of view, so what does an accountant do? He has a service he has to offer. He offers his client, I'm going to check how good or how bad your VAT submission was. And it goes through this list of invoices, hundreds or thousands could be. And he's billing them by the hour. This is actually something that happened to us a couple of years ago. We built that solution, but then quite naively, we thought that they're going to be happy with the fact that we could do it in seconds, what they took them weeks, forgetting that they were billing by the hour. And to change the business model from billing by the hour to a productized model is not only technology, it is not technology, it is just reconsidering how you do business and how you have people work for you, because basically those people need to start doing other things. So this is coming back in many innovations. So on the one hand, you have to go through a lot of iterations, and that's what this picture tries to make clear. If you want to create new products and test products, minimum viable products, there's cycles to go through. If you do not test within that process also, can we actually fit it into the business? Does it fit the business model? It for sure doesn't fit the business process, because you're going to innovate something new. So this is you could say, the soft side of implementing AI or data science projects, where you have to go through many cycles in order to get something to work. And this involves a lot of communication. There's a lot of delays in this. There's a lot of people that need to be involved, and it has, a lot of human elements to it, let alone the ones that are related to the technology and making it easy for people to communicate, to work with your product. So that's the innovation cycle. That's connected to the business model that you probably will be impacting with the products that you develop. Moving on to competencies, because we did quite an extensive work on our side in order to better understand what does a good data scientist look like. So there are over 100 factors here, and the point that we wanted to bring across, and you can see if you zoom in here, there are, 3 things that are very clear to everyone. There is technology and programming. You really have to have a good basis into technology and programming. Everyone understands that you have to have a good background in modeling and what I call methodologies. That's obvious to you, but to many people in the business, it's not. Because quite often we start projects without defining, our premises, our hypotheses. If we're going to do modeling, it's very often overlooked. So, but at university, at least, these things are being properly taught. You can see from this graph that the data piece is bigger. And this is also what I see as a shortcoming of the various people that we see coming into our companies, is that they have an understanding of data, but very often they have limited experience with complex data. And there is no simple data in no company. All companies have multiple systems. Systems have multiple databases. Companies have multiple data warehouses. They have multiple data marts. So it's really very, very difficult to understand the data map of a company. You might try this one out with an IT manager of a company. You could ask him the simple question: do you have an entity relationship of your data of your company? Now, I've done quite a number of talks to IT guys, and I haven't met one guy that had the guts to raise his arm and say, or had the guts, no one dared to raise his arm to say, yes, I have a data model of how my data is structured of my company. That has just become impossible. I think Ger and I are of the same generation. 30 years ago, we used to have people that did nothing else than model the data of a company. Right now, and there's good reasons for it, by the way, because the ERP systems, for a large extent, are moving to the cloud. When things move to the cloud, it becomes less visible. So it's sometimes logical that people don't really know anymore how the data is structured, which is quite strange if we say the data is the new gold, but we don't know how it's structured. So this is a fundamental problem and probably one of the biggest challenges companies have with this whole surge on cloud computing and moving, more flexible processes with all SaaS tools. You just take a credit card and you have a CRM tool. That is great on one hand, but it has a big downside, and this is where you're going to be confronted with. So if I look at the competencies of a data scientist, business analyst, AI specialist, there's a lot of things you really need to get into with regards to the data. Apart from business skills, which are quite logical, there's nothing specific or mind-boggling about that, other than it's also quite a significant group of competencies as well. And this is growing, I would say. There is more need for people that can really communicate the outcomes very well. And the good thing here, and there's a lot of positive developments here, in my opinion, that the tools are becoming better. It's really, the whole animation of models, the animation of data, that's really, jumping ahead quite significantly. So that's really a good thing. Even those that are not so fluent in talking, they become fluent in communicating by using better tools. So what we do is when we support people on their careers, we try to put markers on where you are and where you should develop in it. This has proven to be a helpful tool just to have the discussion. Now, as I already pointed out, that tech is not the biggest challenge. And we did two very interesting cases. We worked on two spin-offs, one in the accountancy and one in the healthcare. And there's a lot of similarities, between keeping a company healthy and keeping a person healthy, you could say, an accountant or someone in health care. So everywhere there's a business model, which I already alluded to, is a big challenge sometimes to change the business model. In the accountancy, a lot of things are hours-based. If you come up with an automation initiative and anomaly detection or optimization or forecasting, you're taking away someone's hours. You have to be aware of that. In healthcare, the different challenge here, what we are doing with the healthcare company is that we basically equip people with IoT devices, so smartwatches, scales, blood pressure meters. We have a lot of different meters, and then basically we can follow someone, either to keep him healthy or have someone recover. So we measure. I think we're creating 1 gigabyte per person per day. So incredible amount of data, the movements, heartbeat, activity levels, anything you know that we're already capable of measuring, we're capturing the data. So, but then if you want to break through there, you have to also break through the existing structure and system, because this current system is completely differently incentivized than what you are capable of doing by preventing someone to get ill. The whole healthcare system is built around getting people better, not to have people keep people at a certain health level. So that's a big conflict. On the regulation, same challenge, although that's with COVID, that is dramatically changing right now in healthcare. In accountancy, there is pressure from the outside to have more regulation, more oversight, more governance, but it's still 10 years behind versus what the data and the technologies are already capable of doing. So there's a big gap you're confronted with there. then the particular role of an accountant and the particular role of a healthcare employee is still very much focused on being compliant, because everyone is really scared that they're making mistakes, sometimes for good reasons, sometimes just to be safe. And most of them are just looking back and not looking forward. So that's another thing, you know, technology-wise, we're quite capable of doing all kinds of scenario analyses or sensitivity analyses or forecasting. But the people that you're talking to are just focused on risk and compliance and looking backward. On the data side, you know, I call it the Excel kingdoms. This world is led by Excel, okay? And Excel is still one of the biggest tools that also data scientists use. Now, good luck, because if you're going into the finance world, you will find that there are many Excel kingdoms around where your help is needed to untangle them and bring down those kingdoms. Healthcare has another type of complexity in terms of the data. It's very closed, it's very unstructured very often, and it seems to be governed, but in essence, it's not. There, things are very, very complicated and tied into many different directions. So, okay, on the tech side, they are relying on us more techies and, you know, modelers. They really like to rely on people that know a lot about that, because they are quite illiterate, although they're highly educated, they're illiterate on this topic. So you'll see these type of challenges, and I guess I take accountancy and healthcare because that's where we've been operating, but you will run into these other challenges as well as soon as you will get into the reality of bringing products to life. So in summary, there is absolutely need in more methodology as an underpinning for everything is being done in business. As I said, many people just start like a headless chicken on using tools. So the good thing is the tools are getting more accessible, and people, you know, you don't have to have a mathematics degree anymore, it seems, to do machine learning. That is only partially true. If you do not have the fundamental statistics, it's very dangerous. Same as my point on the data modeling, where I refer data modeling as the modeling of the data structures here and not the mathematical modeling. Another thing which is very important to look into is in the failures, because everyone is inundated with success stories on AI. You really have to look hard for the failures, and there are much more failures than there are successes in AI and in data science. So be on the outlook for that. Be on the outlook for the complexity of automating AI. Take that into account. Not that you have to do the automation yourself, but take into account the considerations that you have to have in order to make model decisions. Smart data discovery, that's a new territory, which I think is going to be more and more important. Understand the process of innovation. I think that's clear as well. And don't forget that in the end, everyone is a data scientist sooner or later, because we all pivot, we all analyze, we all try to make sense of reality. So I think it's a task for you also to make it more accessible for everyone. I finish off with a maybe not completely politically correct joke not from me, by the way, from a guy called Warren Buffett. Even though we have many talents, if you want to produce a baby, you don't do it in 1 month with 9 people. You know, you need 9 months with 1 person. So we need patience. So that's it for me.
Thank you, Martin.